Okay, question 249. It says a brick is released with no initial speed from the roof of a building. So here's the brick. Starts off at the top of the building. It strikes the ground in 2.8 seconds. So the facts are delta t equals 2.8 seconds. It's going to fall with a similar pattern as the shuttle in lab. It's going to have a very small initial velocity. Initial velocity is equal to 0. Final velocity, we don't know. T initial is equal to 0. Y initial is equal to 0. We don't know the height. Actually, let's not leave it to 0. Let's leave it as a unknown. And indeed, let's put 0 on the ground. So I'm defining a little coordinate system. I'm calling this 0. This is my y-axis. This is plus. Upward is in the positive direction. Downward is in the negative direction. I have a 0, and I have a sense of origin, and I have a sense of direction, plus and minus. So my y initial is an unknown. My final velocity is an unknown. And the question asks first, how tall is the building? Well, we need a kinematic equation. As this thing falls, we can see it's accelerating. We do know the acceleration. The acceleration is 9.8 meters per second squared downwards. And in this case, downwards is in the negative direction. So we want we also know that our final position is equal to 0 because we've called it 0. So we need an equation that connects position with our knowns, which are acceleration and time. Looking at our kinematic equations, I would choose this one. Y final, which we know, 0. Y initial, which we don't know, plus the initial velocity, which we know to be 0, delta t plus 1/2. Acceleration is a constant. Velocity is not a constant. It'll be changing from 0 to speeding up in the negative direction. T squared, that'll do it. The next part, how fast is the brick moving just before it hits the ground? Well, with this answer, we'll have positions. We'll know both positions. We'll know the time. We'll know the acceleration. The only thing we won't know is velocity final. Let's use the second kinematic equation for constant acceleration and changing velocity. Velocity final squared, velocity initial squared. Velocity final squared, velocity initial squared, plus 2a delta y. Delta y, y final minus y initial. All right, I think you can. So basically the lesson here, set up a diagram and establish a sense of motion. Here we have acceleration. Set up your facts, list your facts and your unknowns, and then give yourself an explicit coordinate system. Establish an origin and decide what your directions are. What's positive, what's negative.